Hi pre-calc. Now we're going to use the reference angles. So I'm trying to pick a question like something I'd ask you on a test. So let's try this. Evaluate the sine, cosine, and tangent of 300 degrees using reference angles. You know what? I copied the directions, so if you're just using, it's really just using one reference angle. It's not more than one if you're just doing one problem. Okay. Alright, so let's start by drawing 300 degrees. 300 degrees looks about like that. Okay, it started from standard position, which is always over here on the positive side of the x-axis. Alright, now we're going to find the reference angle. So remember, it's always from the terminal side back to the horizontal x-axis. So theta prime is going to fall right in here. Okay, so let's calculate it. So to calculate theta prime, I have to do, and I gave you the rules, so for quadrant 4 it's 360 degrees. Now notice I'm in the version of degrees because the problem is in degrees. I won't be in I wouldn't use radians. I wouldn't put 2 pi here because I'm in degrees. Alright, so the reference angle here is 60 degrees. Okay, I have to show you one other thing, but let me just write where we're going with this. So what they're asking is for the sine, the cosine, and the tangent 300 degrees. Okay, that's the original question. So let me just make sure we're clear on that. I found the reference angle and I'm about to put it all together, but I have to show you something really quick before I do that. Now, when you evaluate a trig function using reference angles, it has to be a combination of the reference angle along with the correct plus or minus of the trig function in that quadrant. So it's the two things together, the plus or minus and the reference angle, the two things together give you what would be the original. So we're doing this without using a calculator. We're going to do this in our heads, but again, we need to know the reference angle and the sine. So let me now show you the sine. So this just depends how your brain works. Like my brain has a very easy time remembering cosine of theta is like an x and sine of theta is like a y. Meaning by that the plus cosine will be positive where x is positive, cosine will be negative where x is negative. So like for instance, over here in the first quadrant, the cosine's positive, the sine's positive, and since the tangent is the ratio of these two, it's positive because the tangent is sine over cos. And then that also tells you about the reciprocals, what the reciprocal plus or minus is. So this means that the cosecant is positive, the secant is positive, and the cotangent is positive. So it's actually giving you the plus or minus of the 6 trig functions. Okay, so what I was just saying before, Pierre, if you didn't catch it, is cosine is like an x, sine is like a y, and tangent is like a y over x. So if you very easily know that y is positive up, negative down, you have all the values for sine. If you remember that cosine is positive to the right, negative to the left, just like an x would be, you have all of that for cosine. And then you could just do the ratio for this. If you don't like that, there is a mnemonic, which is all students take calculus. All students take calculus, and what this mnemonic does is it tells you who is positive. So in quadrant 1, all of them are positive. In quadrant 2, In quadrant 2, the sine's positive, the cosine is negative, and the tangent, since it's a ratio, is negative. So again, sine is like a y. It's positive up, negative down. Cosine is like an x. It's positive right, negative left. And again, tangent's the ratio. But if you like this little rule I put up here, S means that only the sine is positive, right? So down here, if we try this one with the mnemonic, if we try this one with the mnemonic, it's saying that only the t is positive, or the tangent. And now the last one, only the c is positive. So this All Students Take Calculus tells you who is positive in each of the 4 quadrants. And again, remember, this is also telling you about the reciprocal identities. So if the sine is negative, the cosecant is negative. If the cosine is negative, the secant is negative. If the tangent is positive, the cotangent is positive. Okay? Now let's go back and finish this problem. Now since we're in quadrant 4, All Students Take Calculus, that means that only the cosine's positive and the other 2 are negative. That's what I was just trying to show you. Right? I just tried to show you that here. So now the sign change along with the reference angle the sign change and the reference angle, you need them both together, will be equivalent to what the original is. Okay? So now under this, I'm going to use those triangles I asked you to memorize the other day. So 60 degrees, that's across from the radical 3. Remember, I asked you for memorize 2 triangles and the unit circle. So if you're across from 60, you're always radical 3. If you're across from 30, you're always 1. And for this one, you'll be a 2, right? I asked you to memorize the 30, 60, 90 triangle, and this is now where I'm going to use it. So sine of 60 is the opposite over the hypotenuse. Cosine of 60 is the adjacent over the hypotenuse. Tangent of 60 is the opposite over the adjacent. Radical 3 over 1, or just negative radical 3. Okay, gang, and that's it. That we just did one full question. I'll give you more to try, but let me end this video here. So these, just to make sure I'm totally being clear, these are the answers that I was looking for, and this is done by using reference angles. And on the test and the final, you're going to show me your work that you did these steps. You drew the picture, you found the reference angle, you did the translation, and you got the answer. All right, catch you. Bye-bye.